Hello and welcome to another lecture video on cognitive psychology. This video will discuss about the chapter on problem solving and creativity. Since this is a very long chapter, this lecture video will be divided into two parts. So for the first part, this is the outline. This lecture video will discuss about three major concepts from the chapter. The first one is to discuss the problem solving cycle. Second is to discuss about the types of problems. And the third is to discuss about the obstacles and aids to problem solving. Before we delve into the framework of the problem solving cycle, let's first understand what really problem solving is. Perhaps the main skill that is attributed to cognition is problem solving, and it is one of the cognitive functions that is very necessary for our day-to-day living. We apply a process of thought to achieving a desired outcome or avoiding an undesirable outcome by a process of thought that guides us to take specific actions to effect a positive outcome, and that is problem solving. Whether it is regarded as simple problem or creative problem solving often depends on whether we see the solution as obvious in arrears. Now, problem solving can either be simple or complex. There are times when the problem that we face is just relatively easier for us to solve. We have the resources to solve it, or it could also be very complex, novel, and unusual. And it can also be undertaken by an individual or group, and it is arguable whether working as a group facilitates or obfuscates our problem solving ability. The thing with problem solving is that how we or how people solve problems actually depend partly on how we also understand the nature of the problem. However, regardless whether it's simple or complex, whether we solve problems individually or by group, our problem solving skill is regarded as a distinctive quality of human beings. While some problem solving behavior has been witnessed in certain animal subjects, there are certain researches that um, dealt with the problem solving skills, primarily on primates. It is very rudimentary and problem solving remains a defining characteristic of the human mind. Now let's proceed to the problem-solving cycle. So what is this cycle all about? Now, when faced with a problem or a circumstance, if we if we can quickly retrieve an answer from memory regarding that circumstance, then we don't have a problem at the moment. But if we cannot retrieve an immediate answer, then we have a problem to be solved. So that's when a circumstance becomes a problem. When faced with a problem, we're first confronted by what we call an initial state. So this is a state wherein the situation at the outset in which the problem is not yet solved. You are still presented with what is yet to be solved, a problem that is yet to be solved. Now, our main goal from the initial state is to achieve the goal state, or the state wherein we have effectively or successfully resolved the problem. However, most, if not all, problems are met with an obstacle. So obstacle can literally be anything. So it could be one or several factors that can prevent us from solving our problem. It could be a lack of resources. It could be a lack of knowledge how to solve a problem. It could be you meeting the problem for the first time. Now, when we want to solve a problem, this is when the problem solving comes in. We engage in what we call the problem solving cycle. And this cycle has 7 stages. So the first stage is on problem identification. The second is on the definition of problem. The third stage is constructing a strategy for problem solving. The fourth is on organizing information about a problem. Fifth, allocation of resources. Sixth, monitoring problem solving. And lastly is the evaluation on whether you have successfully resolved the problem. Now, to get a closer look, let's try to discuss each stages of the problem solving cycle. The first stage is called the problem identification. Here, we ask ourselves, do we actually have a problem? No? So again, earlier, if we can just retrieve the answer quickly from our memory, then it's not a problem. But if it's not that easy, then we actually have a problem. So how do we do that? So we may interpret sensory data from the environment to determine that a problem exists. No? So we try to recognize specific environmental cues to tell us that there is actually a problem. Okay, so that's the first stage. So the second stage is problem definition. So here we ask ourselves, what exactly is our problem? Now, the first one, we ask ourselves if we really do have a problem, and if we do, we try to identify, or we try to define what exactly is the problem here. What is something that we need to solve? So once you recognize the problem and acknowledge our ability and willingness to take action, we then must further analyze a problem itself. So analysis here is very important. We need to break down the problem that we have identified to further understand what needs to be solved. So in practical terms, this is a critical step because many solutions fail partly because, or mainly because, the problem was not well understood. So the person wasn't really able to identify which exactly needs to be solved, or what really is the problem. That is, we took action without considering what we wanted to achieve. So this stage is also very essential. Once we are able to clearly define what exactly the problem is, we had analyzed the problem further, then we could proceed to the third stage, which is choosing a problem-solving strategy. Once we have, again, fully analyzed what is wrong in our environment, in our work, in our studies, etc., now we ask ourselves, how can we solve the problem? So for example, your problem could be um, there is an upcoming final exam for cognitive psychology. That's the clear problem that you have. So then you choose a strategy. How can you solve this problem? So there are a lot of ways on how you can choose a method on solving this dilemma or solving this problem, right? So before gathering data about the problem and the intended solution, we must choose a methodology for problem solving. So this would involve either the analysis of the situation as we perceive it, or it could be a synthesis that considers contributing the possible outcome if something outside the situation were added. So this stage, again, could either be a breakdown analysis of the situation, what are the things that you can do about it, or what information or resources could you integrate to change the problem or to um, to solve or to lessen your dilemma. Okay. Now, this stage of analysis and synthesis actually it also involves two types of thinking: divergent thinking, in which we consider a number of possible courses of action. For example, if your dilemma or problem is an upcoming exam, or it could be a departmental exam, you could think of all possible courses of action. It could be you study for the exam, you sit next to the smartest student in class and copy. You could, prepare a cheat code and so many possible courses. But eventually, after we engage in divergent thinking, we must also engage in convergent thinking, in which we merely explore one alternative. That means we narrow down which of the many possible courses of action do we actually apply in solving this problem. And fourth is on researching and organizing information. So we ask ourselves, how do the various pieces of information in the problem fit together? So in the stage of the problem-solving cycle, we gather information about the problem and the solution. So we research more about it, determining which elements of the situation are germane to the problem and which are incidental, as well as any elements we may wish to add to it. Sometimes problem solving fails because, again, people do not have sufficient information. So again, they don't have a lot of knowledge about what the problem really is. whether they were aware of it at the time or not. So this also occurs throughout the problem-solving cycle in that we are constantly observing information and consolidating it into our appraisal. So this basically means that even if we are at the later stage of the problem-solving cycle, we can always jump back to a previous stage and could also skip a stage, again depending on the circumstance or the situation. Now let's go to the fifth stage, which is allocating resources. So here we ask ourselves, how much time, effort, and money and other resources should I put into this problem? If it's a really big problem, then you probably would allot or allocate more time, more effort, more money to it, more resources to it. If it's a smaller, simpler problem, then maybe less. So it is generally accepted that we have limited resources to apply. That is true. In most problems that we meet, there will be limitations to our resources, particularly in terms of time, money, equipment, space, and personnel. So our desired solution may require more than we have available, our resources at the moment, and acquiring the necessary resources may spins off one or more additional problems. But ultimately, um, we arrive at a spot where we have all the resources we're able to get to apply, and we must make the best of what we have. So that is the fifth stage. The sixth is on monitoring. So here, once we have gathered information, we have chosen a strategy on how we solve the problem. We have also allocated all the possible resources that we can, apply to the problem. Then we monitor about the progress of our problem solving. So we ask ourselves, am I on track as I proceed to solve the problem? Are we actually going closer to the goal state, or are we still far? We're actually going farther, the opposite direction to the goal state. So monitoring takes place as we begin to apply the solution to the problem. It's the application. Okay. So here we are vigilant to monitor or to check whether what we are doing is having the desired effect or not. If we are uncertain enough to the outcome, so we may abandon the course of action that we are currently applying to the problem and attempt something else, some alternative, or for some they could give up entirely. And lastly is on the last, and lastly is the seventh stage, which is the evaluation. So here, evaluate, did I solve the problem correctly? Was it effective? Was it efficient? Was it successful? So after you have taken an action applying all methods of problem solving, then we assess whether the action was successful in solving the problem. Did your, for example, going back to the uh, final exam dilemma, you assess, and let's say you chose the um, path to just really study and prepare, read books and watch supplemental videos to prepare for the exam. After the exam, evaluate, was I able to correctly solve the problem? Did I pass? Did I get a high score, or did I fail? Okay, so we evaluate. If it was not successful, then we must continue working on the problem, often considering a different solution. Okay, so if it was successful, then we evaluate the success, if only momentarily, to assess whether it would be best to use the same solution to the same problem in the future. So there are different, again, paths when evaluating. It's either you have successfully solved the problem, so you don't need to think of other solutions. The strategy that you used was not effective, so you choose another one. And if it was successful, you can also evaluate whether your course of action or courses of action that you used could still be applicable in the future, or perhaps maybe you could also try different or improve your strategy should the problem recur in the future. So hopefully those stages are well understood. Now let's try to apply the problem solving cycle in this dilemma or a problem which is running out of toothpaste. So this may be a very simple um, problem that we potentially could, experience at home, running out of toothpaste. Okay, so the first stage is problem identification. Do we actually have a problem? Yes, we do. Which is number two, identifying the problem. What exactly is our problem? So in this case, you had a problem, and that is you ran out of toothpaste or you were running out of toothpaste. And of course, toothpaste is very important for dental hygiene, not unless you are someone who don't really care about your, dental hygiene or hygiene in general. If you don't brush your teeth, if you don't brush your teeth every day, then this wouldn't be a problem to you. Anyway, to those who are brushing their teeth every day, so this is a problem. Now, the third stage is on strategy formulation. So now you ask yourself, how can I solve the problem of running out of toothpaste, and what strategies could I, use involving this problem? So you could analyze what's the problem, or you could also synthesize whatever information that you can synthesize to solve the problem. And then fourth, you organize the information. How do the various pieces of information in a problem fit together? Maybe later on, you the information that you've gotten from the past, when you run out of toothpaste, you have organized it and you have synthesized it, to choose a problem strategy, which is you could either choose to squeeze all the remaining, use all your strength to the um, squeeze out the remaining toothpaste if there are really some, or you could, just go out to your house and go to the nearest convenience store and buy some toothpaste, right? So those could be different strategies that you can use. Fifth is resource allocation. Do you really need to put a lot of time to it? Really think of, strategies on how you can solve this dilemma, or maybe you could just, go outside your house and just buy a toothpaste. Does it need a lot of effort, a lot of money? Probably not. Okay, and then six is you monitor. Let's say you chose to just go out your house, and just from the nearest convenience store. So you monitor and then evaluate. Did I solve the problem correctly? Yes, you did, because you were smart enough to just buy a new one instead of forcing yourself to squeeze all the remaining toothpaste that was not even worth it in the first place. So here you go. So that's just, another example on how we can use the problem solving cycle in maybe a very superficial problem that we face at home, such as running out of toothpaste. Okay. Now that we understand about the cycle, the problem solving cycle, let's discuss the different types of problems. So there are actually different types of problems, and problems can be categorized according to whether there is a clear path to a solution or whether there is a lack of clear path to a solution. Okay? So there are two types. We have the well-structured problems, which have clarity to it. So in well-structured problems, we know what we want to achieve and have a high level of confidence in the actions we must take to solve it. Okay? While for the other types of problem, which is the ill-structured problems, again with the lack clear paths to solutions, we don't know. We know we don't like where we are, but don't know where we want to go. So in ill-structured problems, that's their dilemma. You know that there's a problem, but there's no clearly defined boundaries as to how you can actually solve a problem. There are so many ways on how you can solve this problem, and so a lot of paths could be taken to solve this problem. So it's not clear, or there is no clear course of action to follow. No? So we know where we want to be, but it's just that we just don't know how to get there, how to actually solve the problem. So those are ill-structured problems. Now, before we delve into these two, in the real world of problem solving, in our day-to-day problem solving dilemmas, these two categories are approached in much the same way actually, and they merely represent the extremes of a continuum of the certainty of problem solver. So sometimes a problem could be more or less leaning towards a well-structured problem with just very, very little ambiguity. And some problems could be leaning towards the ill-structured problems with more, ambiguity and uncertainty. Okay? So a well-structured problem becomes ill-structured when things do not go as planned, and an ill-structured problem could also become a well-structured one when a definite solution comes to mind. So it can actually, um, slide from one side to the other. It depends on the clarity and the steps that you need to engage. Again, in well-structured problems, there are specific or clear paths that you can take. Or for ill-structured problems, there's no one clear exact path to solving the problem. Okay. Now let's discuss more about the well-structured problems. Okay, so what could be examples of well-structured problems? Most of the well-structured problems that you meet are in the academic setting, which are your exams in math, in history, in biology, in chemistry. So, for example, when you take your chemistry classes, if your teacher asks you to balance this specific chemical um, formula, then you know that there is a definite way or clear path as to how you can balance the formula, right? There is a clear solution. Or when you, for example, when you are asked to find in calculus to find the limits, or in geometry to find the area, to find the um, circumference of a circle, there is a clear formula for you to apply to arrive to a definite solution, right? A definite answer. So those are well-structured problems. So most of the problems or the exams that you meet probably are more or less well-structured. Maybe a few ill-structured problems in some other fields, no? Wherein you're given a problem or situation that has several or multiple ways on how you can achieve the goal state. Okay, so to further discuss about well-structured problems, here is an example activity which is also in your book. So this is on the activity on the move problem called the hobbits and the orcs problem. Okay, so this is the how the problem goes. Okay, so this is how the problem. So you can see here in the picture on the left and the right. So the left represents the initial state and the right represents the goal state. So this is the problem. Three hobbits and three orcs arrive at a river bank, and they all want to cross to the other side. Fortunately, there is a boat available, but unfortunately, it can carry only two creatures at a time. What really makes the situation complicated is that the orcs are vicious creatures. Take note, they are vicious creatures. Whenever there are more orcs than hobbits on one side of the river, the orcs will immediately attack the hobbits and eat them up. So that's the problem. How can they cross the river again without having any hobbit to be eaten by an orc? Consequently, you should be certain that you never leave more orcs than hobbits on either river bank. Although the orcs are vicious creatures, they can be trusted to bring the boat back. So your challenge now is to move all six creatures across the river without allowing the orcs to eat the hobbits. So this is a really good problem-solving activity. So again, The initial state, the initial state is that there are 6 creatures, 3 hobbits and 3 orcs, and the goal state is for all of them to be um, or to cross the river using this boat. However, one of the obstacles in this problem is that you need to make sure that when you transfer these creatures, there will be the orcs shouldn't outnumber the hobbit, or else they will be eaten, and that's the problem there. Okay, how can you move them without any hobbit getting eaten? Okay, so if you want to know the answer, you can try, you know, these problem, or if you're too impatient, you can just look for the answer. Okay, now basing on the problem earlier and other well-structured problems, what could be the 3 kinds of errors that one may meet in solving a well-structured problem? Okay, the first error that we mostly do in solving a well-structured problem is to inadvertently moving backward. That is, we try to revert to a state that is further from the end goal. So the thing, when we move backward, it could actually lead us further from the goal state, which was in that activity to transfer all of the orcs and hobbits on the other side of the river bank. Second is to make illegal moves. That is, we try to uh, apply a course of action that is not applicable, or there should not be applicable to the problem. An illegal move in the terms of the orc and hobbits is that a move that is not permitted according to the terms of the problem. So when you try to do this activity, you will realize that there are actually illegal moves. For example, an illegal move is to, again, um, put them put all 6 of them on the boat, because again, the terms is that only 2 creatures can ride a boat at the same time. So putting all 6 on the boat at one time is an illegal move. You can't do that. So in well-structured problems, there are also things that you can't do to solve the problem. Okay, whatever that move is, it depends on the problem. And third is not realizing the nature of the next legal move. So people become stuck because they don't know what to do next given the current stage of the problem. So they don't know what to do next because they also fail to see what could be other next possible or legal moves that they should be doing. So for example, one of the dilemmas for people, no, when solving this the hobbits and orcs problem, is that they fail to realize that when they move 2 creatures at a time, for example, they let's say load, let's say, 1 hobbit and 1 orc, for the first trip, they can only leave one of the creature from the boat on the riverside, because one creature should bring the boat back to the previous side of the river bank. So that's something that most problem solvers fail to realize, that it's actually something that they should do. Okay. Now, um, to further the understanding of well-structured problems, most researchers would develop programs. So computer simulations are developed to further understand how to solve well-defined problems, and it has helped progress the understanding of how human beings also solve well-structured problems. By developing the instructions a computer must execute to solve problems, so the researcher may better understand how humans solve similar kinds of problems based on these computer simulations. Now, according to one model of problem solving, the problem solver could either be human or the computer program, must view the initial problem state and the goal state within a problem space. So that's the first term we need to understand, the problem space. Now, the problem space is the universe of all possible actions that can be applied to solving a problem. So again, all the whatever universe of all, again, actions that you can do to apply, that you can apply to solve a problem. giving any constraints that apply to the solution of the problem. So that's the problem space. Now, in practice, class, the problem space is not necessarily a universe of possible actions. It's actually only limited, especially with our human ability, okay? So it is limited to the breadth, to the scope of your human insight. So again, it also has its restrictions. When the solution is unclear, we can brainstorm every possible course of action and evaluate which of them will be the most effective or efficient in solving the problem. But even if we brainstorm every possible course of action, we will still come up with limited numbers of um, course of actions. But we must choose the most effective or efficient strategy. Okay? In practice, we are often limited by our cognitive capacity. That is true. So there may be 100 or 1,000 different options to explore, but we are only capable or able to consider a smaller set at any given time. So that's also the restrictions of the problem space. So if we try to force ourselves to, consider all possible actions, though we may just end up failing to consider a promising solution because we have overloaded our mental capacity. Okay, so that's a problem space. Okay, now all these assumptions, no, the possible course of actions, can be tested by algorithms, at least in the context of computer simulations, to determine the likelihood of success. Sometimes this can be done mathematically, but other algorithms can also be raw logic. Okay, but it's easier to be done by computer simulations. So an algorithm is characterized by the consideration of success criteria and the matching of a proposed tactic against them. So it tries to see which of the possible course of action is most likely effective. So algorithms refer to sets of procedures within your problem space, again, that may be repeated over and over again and that in theory guarantee the solution to a problem. So generally an algorithm continues until it satisfies a condition determined by a program and things like that. Okay. But however, because of our limits, again, as human beings, again, we don't have the capability to test all these possible, by like the algorithms of a computer. So human beings instead use mental shortcuts or what we call heuristics. So heuristics are informal, intuitive, speculative strategies that sometimes lead to an effective solution, but sometimes it also doesn't. Okay. So unlike algorithms, which can be mathematically computed, no, to have a objective number of solution success rate, we just use heuristics. So heuristics are just another method of assessing a tactic. A standard set of question is applied to each alternative one. So when we use this in, trying to check whether a solution is effective, so we ask ourselves, what will happen if we use this alternative over this one? What resources will it require if we use this path over this one? What are the possible unintended side effects if we choose option A compared to option B compared to option C? So to um, see heuristics, clear. So here is a table on heuristics. We have the means ends analysis, we have the working forward, we have the working backward, and generate and test heuristics. Okay, so I will not read what is there um, in the table. Now, problem solving also tends to be narrative in nature. No? So we try to talk in ourselves rather. So we can work forward from the present situation to the desired outcome. That could be, our course of action. Or we can work backward from the desired outcome to the present situation in order to discover what must be done to solve the problem, what can be improved, etc., etc. So in effect, we are telling a story of a sequence of events, imagining the effect of each action. So that is why it's a narrative in nature. So we try to visualize, think of the possible course of action, course of the problem, given these sets of strategies that we want to choose to solve the problem. Okay, so here is an example. Let's just say, um, how do we find a certain, let's say for example, you're already in your thesis stage of your BS psychology degree, okay, and one of the tasks for having a thesis is to do a literature review. So let's just say, for example, you want to find this very, very important textbook in the library for your thesis, for your certain topic in your thesis. So you ask yourself, how do you find a given book, the certain book in a library? No, there are so many possible in a problem space. There are so many possible course of action, right? So one option is to check every book in a systematic method. Could be through the computer system in the library, right? Or it could also be to check every shelf in every row in every room to find it. Could also be a possible course of action. Or it could also be to think of, if you I know you know this, right? That in the library the books are of course in any library it is classified under which area it is, right? In a field, is it in science, is it in philosophy, is it in psychology, is it in history, and things like that. So maybe you could also opt to choose that method to check the history section, to choose the psychology section, and in the psychology section, is it under clinical, is it social psychology, is it industrial organizational psychology, and etc., etc. Okay. Or you could also assume that books are accurately shelved by category, I said earlier, or alphabetized by author to limit that search. Or you could just ask the librarian to help you, search for the book. Okay, so that's for the well-structured problems. Now let's delve into the ill-structured problems. So before we delve into the ill-structured problems, let's first consider this problem. So let me read this problem. A woman who lived in a small town married 20 different men in the same town. All of them are still living, and she never divorced any of them. It's like a riddle. Yet she broke no laws. How could she do this? Okay? So if you can see here, unlike from the problem earlier of the hobbits and orcs, there are actually certain, if you remember, your clear set of actions is just to strategize how, the what they call this, the pairings of orcs and hobbits that you should do, in placing them in a boat. What's the certain order, certain sequence? But there's a clear path, right, on how you can transfer the orcs and hobbits to the other side of the bank. Here, more or less, there is less or no structure at all on how you can solve the problem. How can a woman marry 20 different men in the same town at the same time they're all alive, but she never divorced any of them without breaking any law? So again, there's so many ways on how you can see this problem and arrive at a significant solution. So again, this problem actually has certain possible answers. So what could be the answers for this problem? Here we go. Okay, so here are the possible answers to it. The first answer could be the woman was actually a minister or someone who could actually marry people. So there in the problem, the term married could actually depend on the context. It could either be you're the one getting married, or you, as a priest, a pastor, a minister, married a couple. So that's some one solution to look into the problem. So the woman is a minister who was involved in multiple marriages. Okay, again, the critical element for solving this problem is to recognize that the word married may be used to describe as the performance of the marriage ceremony. So technically, she didn't break any law, and all of them who got married, the men whom she married to another woman, were still alive. So basically, it's still a solution to the problem. Okay, and there are also other additional possibilities. The woman could be an actress, and in the role that she played in a TV series or a movie was that she has to marry the man in the drama. So technically, she married these men, but as a character in the um, TV series or the movie. So she also technically did not break any laws for divorcing them. Or the woman's multiple marriages were annulled, were because of annulment. So technically, it's not divorce, right? It was annulment, not divorce. So technically, she was still able to marry 20 men. They were still alive, and she never divorced them because she annulled all of them. And another one is that maybe her husband changed his name 20 different times. So basically, it's like being married to 20 different men because your husband changed his name 20 times. So it's like getting married to 20 different names. Okay, so those are possible answers to this problem. Now, again, in ill structured problems, there are no clear, readily available paths to a solution. So, by definition, ill structured problems do not have well defined problem spaces. So, problem solvers have difficulty constructing appropriate mental representations for modeling these problems and their solutions. So, what is important in ill-structured problems then? So, justification skills are important because ill-structured problems can be represented in different ways. Just like earlier, right? The term married can be represented in different ways and often have alternative solutions. Thus, problem solvers need to choose and justify their selection of a particular representation and solution. So, therefore, the preceding ill structured problems are insight problems because you need to see the problem in a different, novel way. So, insight is a very important skill or ability in solving ill structured problems. In particular, you need to see it differently from how you'd probably see the problem at first, and differently from how you would probably solve problems in general. That means you need to restructure your representation in order for you to um, solve the problem. In solving the area of a specific, let's say, um, shape, you don't need to really restructure your problem. I mean, restructure your representation, right? You just really need to uh, know which correct formula to use. But here, you don't. So, insight is a method of recognizing some peculiarity in the situation that leads to a clear path to success. So, in some instances, it has to do with the wording of the question, just like earlier in the problem. Often, insight involves reconceptualizing a problem or a strategy in a totally new way. Again, it's a distinctive and sometimes seemingly sudden understanding of a problem or a strategy that aids in solving the problem. That's insight. So, insight often involves detecting and combining relevant, old, and new information. So, it's really, um, it doesn't have a structure again, to gain a novel view of the problem or of its solution. Although insights may feel as though they are sudden, they are often the result of much prior thought and hard work. So, it's not just something very intuitive, no, something that just popped in your head, but it's often a result also with your prior thought and hard work. Okay, so that is on ill-structured problems. Now we discuss on what three factors that could hinder or facilitate problem solving. So there are a few concepts that we need to understand. Now, several factors can hinder or enhance problem solving. Now, first, let's talk about factors that most likely hinder an individual to solve a problem. So, the first one is a mental set. So, what is a mental set? It is an individual's preference for an existing model for representing a problem or interpreting its parameters. It means it is a set of thoughts, set of thinking. It's a model. It's a framework in your mind that you apply every time you meet a problem. Take note, not all problems are the same, and even if they look similar, there can still be nuances between these problems where your existing model, your existing mental set may not necessarily be applicable, right, and effective in solving that problem. When a person becomes entrenched, so mental set is also called entrenchment, in a particular framework, he attempts to apply a strategy for problem solving that is not suited for a situation. So again, this can be problematic. So if you are too inflexible, is that a term? If you're too rigid to think of other ways of solving the problem, because again, we already have this preference of an existing model, then we may not be able to solve some problems that we meet in the future. Okay, so until we abandon a certain mental set, then we couldn't solve effectively a certain problem that is not suited for existing mental set. In general, a mental set is adopted because it is effective. Of course, that's your preference because it has worked for you for quite some time in solving routine problems in the past. Um, and the problem solver does not recognize that the present situation is not necessarily similar to the previous ones. So again, that is something that we need um, to be aware of. Next is on functional fixedness or fixation. So it's a similar problem to mental set in which a person considers only the customary use of an object and fails to recognize that it can be used for other purposes. Okay, so um, this is when we feel we only fixated that this specific resource or this specific object can only be used in this specific problem, failing to recognize that it can also be used in different strategies or I mean different situations, right? Um, like what could be examples? I can think of any. Mm, here, I actually prepared an example here. So, for example, in a common survival puzzles that ask participants to rank the importance of various items found in the debris of a wreck ship. Okay, so this is a survival puzzle. No? So again, participants are asked to rank the importance of various items you can see in a shipwreck. Okay, so of course you can see there maybe life vest, chairs, or a first aid kit. You can also see there garbage bags. You can see there fire extinguishers, etc., etc. So among these debris, garbage bags are often considered to be one of the least useful items. Why? Because we are usually fixated on the fact that garbage bags can only be used to, of course, contain garbages. But in fact, if we actually try to see the garbage bags in a different light, it can be actually used in other functions that could help us survive. What? Like what? So garbage bag is a sheet of plastic. It can be used to create a shelter. For example, when you are stranded on an island, you can use it as shelter, right? It could be a roofing. It could be used to store food when you um, uh, go through this deserted island and maybe you find some food and some things that you can use, collect and use. You can use the garbage bag to um, to store these items. You could also use the garbage bag to um, as a clothing. If your clothes are wet, maybe you can wear a lot of garbage bag, and it could make you feel more or less warm, right? You could also use it to store water, right? So again, garbage bags can actually have a lot of uses other than being used as a storage for garbage. So again, if we are functionally fixated, then it could also hinder our problem-solving skills. Next is on transfers. Could be negative or positive transfers. Now, either can be an obstacle or an aid to problem solving. Now, in general, our experiences enables us to solve not only routine problems, okay, but also unusual ones, so peculiar ones. Because certain of our problem-solving skills are actually transferable. So this is the concept of transfer. So one problem may be different from the ones we have encountered before, but we can see that the ones we used before can be applicable to this problem. Okay, so this usually works out for the better, but can become a hindrance if they are not really applicable to the situation and our mental set prevents us from considering the problem in a different light. So there are two types of transfer. So again, transfer is the application of knowledge of skills from previous problem solving situations to new ones. And there are two. There are positive transfers and negative transfers. So positive transfers uh, occur when the transfer facilitates the solution of the new problem. That means it aids a problem because our previous knowledge was able to facilitate the solution of this new novel problem. However, it becomes a negative transfer when it hinders the ability to solve the new problem because again it's not applicable and our mental sets also hinders the solution. Transfer may apply to any part of the problem solving process, our assessment of the nature of the problem, right? Our ability to identify a positive outcome, our consideration of the resources at our disposal. If we have prior knowledge, oh, maybe this is the resources that we can use to this problem. Our consideration of the rules that require specific actions. No, that is transfer. So transfer is also not automatic. No? So people generally do not automatically attempt their preferred method of problem solving without considering whether the problem is isomorphic. So isomorphic is a term when two problems are structurally the same. No? So there could be nuances, but they're more or less the same. So therefore, a specific problem-solving strategy could be applied to this new problem because they are isomorphic. However, they do use certain analogies to determine whether a new problem is similar enough to previously encountered ones for their existing knowledge to apply. So again, we don't just automatically transfer knowledge. We need to also think whether our knowledge from previously encountered problems also apply to the new one. As such, transfer of analogies leads people to make assumptions about situations that don't hold true, either by failing to recognize their characteristics or ascribing characteristics they do not have. So we need to be careful when we transfer analogies, no, of these new problems because we might make assumptions of the new problem based on what we have understood from a previous problem, even if it's not true to this new solution. Okay. And lastly is incubation. So incubation is the practice that refers to putting a problem aside for a while, no? Giving your time space. What? Giving your sorry, what did I just say? Giving yourself time and space to avoid a problem. So avoiding actively to avoid actively thinking about it and is generally regarded as an effective strategy in avoiding negative transfer and superficial evaluation. So incubation enables you to clear your mind, no? So you wouldn't be fixated with a specific strategy, and when you meet the problem again, you have a fresh perspective or fresh look on the problem. Um, Incubation is most common when a subject has attempted to solve a problem and failed. No? Just need some time and space, distance yourself from the problem. They recognize that the approach they're taking is not likely to be productive and break off from activity to clear their minds and start afresh, or simply to set aside prejudices for or against a potential course of action to gain sufficient confidence to act upon it. Now, when we engage in incubation, it allows our subconscious mind to work upon the problem as well as merely allowing the conscious mind to effectively reboot itself so we could get rid of distractions. Um, so both suppositions, the assumptions on subconscious mind and conscious mind may seem plausible, but again, it has not yet effectively proven. Now, there are different benefits on the incubation. So one could be on our memory. So active memory has a limited capacity, and holding onto certain information prevents us from considering any additional information. So if we just give ourselves, time to distance ourselves from the problem, then we are actually helping ourselves to regain our memory's ability. So by dumping the data from working memory, we might notice aspects or follow a tactic that is more effective. It also requires time to compare new information to existing memories. So such that waiting a while may enable us to make connections that were not immediately apparent when we were dealing with the problem earlier. So the time we spend regarding a problem without actually thinking about it may enable us to recognize more details. So again, it's really, really good to sometimes just step away from the problem. Much in the way that we notice more details about a painting or a scene, the longer we look upon it or recognize the qualities of a sound after it has persisted for a while. Okay. So the benefits of incubation are enhanced by giving a solver time to think in an unstructured manner without being fixated, without being um, restricted with mental sets, devoting more time to his consideration of the situation and proposed courses of action. So the luxury of time also encourages the problem solver to think of alternative courses of action rather than rushing to act on the first thing that comes to mind. So incubation is most likely an aid to problem solving. So there you have it. So this is the concepts of the first part of the lecture on problem solving and creativity. So stay tuned for the next video. That's all for today.